So let's take a look at taking the derivative of integrals. So whenever you try to take the derivative of an integral from some constant, I'll just call it a, to a variable u of f of t dt, since the derivative of the integral will cancel out, you can just put the u in the function and multiply by u prime, similar to the chain rule. So it would be f of u times u prime. So looking at number 1, if we were to take the derivative of the integral from 1 to x of sine of t dt, all we have to do is put the x in the variable, or for t in the function, and multiply by u prime. So if u is x, then the answer would be sine of x times the derivative of x was just 1. So our answer will just be sine of x. Now for number 2, let's say we're trying to take the derivative of the integral from x squared to 2 of t plus 3 to the 7th power dt. And notice how the x squared's on the bottom this time. And so we need to make it so that the integral is flipped and x squared is on top and the 2 is actually on the bottom. And remember how the integral from a to b of f of x dx. So if we were to flip the bounds, so we instead say the integral from b to a, it would just make the integral negative. So if we do that and we add a negative, then we'll be able to solve the integral or the derivative. So we can say the derivative of the integral from 2 to x squared of t plus 3 to the 7th dt. And since we flip the bounds, we can make it negative. And so now to evaluate, I can plug in x squared for t and multiply by u prime. So we get negative x squared plus 3 to the 7th power multiplied by the derivative of x squared, which is 2x. So the final answer will be negative 2x times x squared plus 3 to the 7th power. Now let's say we're taking the derivative of the integral from x to x squared of the square root of t squared plus 8 dt. So whenever you're trying to take the derivative of the integral with two variables, we have x and x squared, then we're going to have to split up the integral. So if I were to split this up into two different integrals, I'll put the derivative of the first integral, and for the first integral I'll just put the bottom bound on the bottom, so x. And then on the top I can put a constant, or I just like to put 0 since it's easiest, of the square root of t squared plus 8 dt plus the integral. I forgot to add the derivative. So the derivative of the integral. Now I put the top bound on the top, so x squared, and I can just put whatever I put here. So I put 0 there, of the square root of t squared plus 8 dt. So now I can evaluate these one by one. So let's just start with this integral. Notice how the x is on the bottom, so I need to flip it and make the integral negative. So flip the bounds. I get the derivative of the negative integral from 0 to x of the square root of t squared plus 8 dt. And then if I were to evaluate this integral here, plus, it's in the correct form, so I can just plug in x squared to the function. So I get the square root of x squared squared plus 8 times u prime. And so if u is x squared, then du would be 2x. So don't forget to multiply by u prime always, because it's like a chain rule. And so if I were to evaluate this side further, just plug in x into the function. So I would get negative the square root of x squared plus 8 times u prime, but u prime is just 1 because the derivative of x is 1, plus this function here, so we get 2x. I'll just put the 2x in front, times the square root. X squared squared is x to the 4th, plus 8. And that's the final answer.